Let's attempt to find the equation of the tangent line to the graph of f of x at x equals c. The first one is f of x is 6 over x plus 2x, which is graphed in red below from this graph from desmos.com. And you want to find the equation of the tangent line to the graph at x equals 2. And as you can see, at x equals 2, this blue line is the tangent line to the graph, and you want to find the equation of this line. Now, if you want to find the equation of a line, you need two things. The first one is the slope, and the second one is one point on the line. And if you know these two things, the equation of the line is going to be y minus y1 is equal to m times x minus x1, where x1, y1 is the point, that's the point, and m is the slope. So how can we find the slope? First of all, well, to find the slope, you can differentiate and you can find the derivative of f of x. So and how can you differentiate? Well, f prime of x is going to be, well, the 6 over x is same thing as 6 times x to the negative first power. So to differentiate, you can bring this negative 1 down, and 6 times negative 1 is negative 6 times x to the negative 1 minus 1, or negative second power. And the derivative of 2x, or the slope of the line 2x, is going to be 2. So you have negative 6 over x squared plus 2. So what's the slope at x equals 2? Well, you can just plug x equals 2 into it. F prime at 2 is going to be negative 6 over 2 squared plus 2, which turns out to be negative 6 over 4, or negative 3 halves, plus 2, also known as 1 half. So we know the slope in this case is 1 half. How about the point? Do we know any points on this line? Well, when x is 2, you want this graph to coincide with the graph of our function. You want the line to coincide with the graph of our function. You want them to touch each other. So at x equals 2, you want the y value of this point to be whatever you get when you plug 2 into the function. So let's do that. What's f of 2? When you plug 2 into f, well, you get 6 over 2 plus 2 times 2, which comes out to be 3 plus 4, or 7. So 1 point on this line is going to be 2, 7. So how can you write the equation? Well, you just follow the y minus y1 is m times x minus x1. You have y minus y1, which in this case is 7, is equal to 1 half, which is slope, times x minus x1, or x minus 2. Or you can, if you want to, you can simplify this to y minus 7 is equal to 1fx minus 1, or y, even more, y is 1fx plus 6. So that's the equation of the line. You can use this, or you can use this. They're the same things. Let's look at the second one. F of x is sine of x minus 2 times cosine of x, where our x value is pi over 2. Well, this is pi over 2. And you see the blue is the tangent line that you're trying to find. This graph is also from desmos.com. Now, to find the slope, let's start by differentiating. F prime of x, the derivative of sine of x is cosine of x. Derivative of cosine of x is negative sine of x. So negative 2 and negative. So positive 2 times sine of x. So what's f prime of x at pi over 2? So what's f prime at pi over 2? Well, that's going to be cosine of pi halves plus 2 times sine of pi halves. Cosine of pi halves is 0. Sine of pi halves is 1. So 2 times 1 comes out to be 2. So the slope of this blue line is going to be 2. How about the point? Well, you want to find the coordinate of this point, and you can find, the x value, x is pi halves. You can find y by plugging pi halves into f. So f of pi over 2 is going to be sine of pi over 2 minus 2 times cosine of pi over 2. Sine of pi over 2 is 1, cosine of pi over 2 is 0, so you get 1 for the coordinate of this point. So the coordinate is going to be pi halves 1. So now you can just plug it into y minus y1 is m times x minus x1. Y minus y1, in this case 1, is equal to the slope, which is 2 times x minus pi halves. You can simplify this if you want to. Y minus 1, 2x minus pi, or y is 2x minus pi plus 1.